Welcome. We're already at day 4 of GoDataFest 2020. GoDataFest is a 5-day event celebrating everything in data technology. I'm your host, Jasper Gin, and today we will discuss everything Microsoft. I'm pleased to be joined by René van Osnabrugge as my co-host today. Welcome.
Thank you very much. Thanks for having me.
Yeah, absolutely. You're a DevOps strategy consultant working for Xpirit in the Netherlands, using modern technologies and implementing continuous delivery, DevOps practices, and coaching in the domain of Scrum and Agile.
It's a mouthful, yeah.
Yeah, it's quite a long sentence. You are also an active blogger and speaker.
Yeah, so I think 15 years ago I started blogging about just stuff that I didn't remember quite well, so it was only for myself.
Yeah.
But yeah, eventually people started reading that stuff, and yeah, from one came another, starting to talk national conferences on the same topics, and then moving to international eventually. So Las Vegas, Orlando, it's all on my bucket list, and I've been there, so that's great.
Excellent. Are you looking forward to today?
Yeah, I am very much looking forward to today because this is quite a for me a new space. It is stuff that I come along more and more often, but it's new, and so I'm very excited. Yeah.
Excellent. The Microsoft Azure stream covers a broad range of topics. In 2.5 hours, you will gain insight in the latest product developments and innovations from Redmond. You will learn about data science landing zone and get close to the action at enterprises like Ahold and Eneco, who will discuss their data platforms and AI maturity journey. But first, we are pleased to be joined by Dennis Mulder, CTO of Microsoft Netherlands, to give the opening notes.
Hi there, and thanks GoDataDriven for organizing this full day of Microsoft technologies. I certainly hope it will benefit you all. What I'd like to do in the next 10 minutes or so in this opening is walk you through Microsoft's Azure AI approach and highlight a few of our key technologies as well as progress we've made with customers. I'm Dennis Mulder, I'm the CTO for Microsoft Netherlands, and I work very closely with our internal organization as well as with our customers in the adoption of cloud technologies. So let me first start with the Microsoft mission, right? As we consider the opportunities and challenges facing this world and organizations, we have this enormous responsibility to ensure that technology we build benefits everybody on the planet, including the planet itself. Our purpose and actions must always be aligned to help solve the world's challenges, not create new ones, right? And this is what grounds us in our mission, to empower every person and every organization on the planet to achieve more. And that includes you as AI developers and data scientists. And we want to enable you to make this mission happen, basically. So when we look at the broader Microsoft ecosystem, what we'd like to, the way we look at the world is we have this intelligent cloud and intelligent edge, right? Everybody relies on these devices. There's a lot of sensors in play across the world. It's really a multi-device, multi-sense environment. And not all of the compute the world needs will run in the cloud, right? A lot will run on the edge. So we need to build this experience and platform that spans all these devices and all of these sensors and really capture the data and leverage the ubiquitous computing that we have available in this world now to manage this complexity out of all of the events that come out of the devices. And then apply intelligence to really infuse AI technologies to reason over the data so that we can build the experiences that the world needs. So what we see really across all industries and all business models of the organizations within them is that they will be driven in a large part by applying new technologies to more intelligently engage customers, empower employees, optimize operations, and transform products. What do we mean by that? So basically what we call this is the digital feedback loop. And what we mean by the digital feedback loop is that across those 4 areas that every organization really has, a lot of data is generated. And we need to reap the benefits out of that data by bringing this in a central piece where we can apply AI to benefit all the different areas, right? Data that comes out of products can become a great productivity enhancement for employees, or it can be has information that's required to engage customers in a better way. So this is kind of the mental model that we use, the digital feedback loop, to show you the data that comes around and really put AI in the center to provide the needs of organizations. So now that you know why customers choose Azure AI, what are we doing to equip you in your personal AI journey? So our promise towards our customers is grounded in 3 core principles. The first one is on your terms. We are focused to make sure that we empower developers or anyone using technology in the broadest sense of all skill levels to enable you to use the tools and languages of your choice. So it's not only about Windows, SQL, and .NET, as I'd like to call it. It's all about the technologies that you already use. Then what our promise is to everyone is to run this in a mission-critical way, right? We want to enable organizations to deploy the work that has been created with confidence into our platform. So from that perspective, our platform is fully hardened for the most demanding workloads that literally companies rely on as their lifeline. And then last but certainly not least, we want to do this in a responsible way. We have this uncompromising commitment to responsible AI, built on the most trusted cloud, Azure, with the best privacy controls and responsible AI capabilities and compliance certifications that are bigger than any other cloud in the world. So what is Azure AI? So Azure AI is a set of AI services that are built upon Azure and are deeply integrated with the rest of our Azure stack. Think our data platform, think our app development, think our tools to enable you to build AI into your applications. So at the bottom, we have Azure Machine Learning Service. This is a service that allows data scientists and developers to build, train, and deploy models. It's the only cloud ML service that enables any developer of all skills to apply either a code-first experience or a drag-and-drop way to develop solutions. No matter how models are built, you can store them into the Azure Machine Learning Registry and leverage those. It also contains a lot of open source capabilities. You can leverage Python and any other language that you use today. Then on top of that, we have our customizable AI models. Customizable vision, speech, language, decision models. Those are built with Azure Machine Learning, but we offer developers the most comprehensive set of domain-specific pre-trained models, over 30 in various categories, which are all based on our breakthrough research. And not only does Azure AI have the most number of pre-trained models, we are the only ones that also allow the deployment of those models both in the cloud and in the edge. And in some cases also on other clouds through the use of container technologies. And then we have our scenario specific services, our cognitive capabilities that are pre-baked services such as the form recognizer that you can train on your forms, configure your forms in and do text recognition, for example. Or video indexer is pre-trained to detect over 400,000 famous people and extract words that are in videos like this one. So what we do with all of our technologies really is make sure we test it at scale. In our own solutions, right? Dog fooding at Microsoft, it has become a term. So all AI models that are used in Microsoft products such as Office, Xbox, and other services are trained on Azure. Not only does Azure enable Microsoft data science teams to train those sophisticated models, also Azure serves as the core inferencing platform for all Microsoft products. So in the last few months, we've seen close to 2 million hours of speech transcribed in Teams meetings, thanks to Azure services, using basically the speech cognitive service that you can also use. And then one of my favorites, the PowerPoint Designer. If you create this very boring slide, we use AI machine learning to kind of infer what your intent and give you a few suggestions on what the slide could look like in a nicely graphic way. And then last but not least, Xbox. The Xbox dashboard, when you start that up, provides a very personalized experience that is based on our AI technologies. I hinted on MLOps briefly. MLOps is basically DevOps for machine learning, and it enables data science and IT teams to collaborate and increase the pace of model development and deployment through monitoring, validation, and governance of machine learning models, right? In an ideal world, your ML model will evolve over time. The data may change. You want to govern this in a good way. And MLOps solves for that. So here in this slide, you see a screenshot of DevOps, our DevOps product with an MLOps pipeline, a deployment model. So when you create this great ML model, but the input data starts to deviate a bit from the data that you use in the model, you obviously need to retrain. And this is where Azure Machine Learning and MLOps can help. So it can provide this pipeline of deployment of models, retraining of models in an automated way, just like you used to in a DevOps world for code first development. It kind of takes care of this whole loop. I alluded to this before. Our tools are open and interoperable, and this is the new Microsoft of the past few years, right? Azure ML really provides the flexibility for anyone to use the technology and tools of their choice and run it in Azure. You don't need to change your habits. You don't need to unlearn or relearn things. You can use Python, you can use Jupyter, you can use many services that you're used to. It's really simple, right? We give customers the flexibility to choose their deep learning framework, their language, without locking you into individual frameworks. But run it in Azure using MLOps technologies, for example. So let me highlight a few customer scenarios that we've seen a lot in the past, right? So AI for new business and process optimization. What we mean there is optimizing supply chains, right? Making sure that you don't have a lot of stock, that you really streamline the process to create products. This applies heavily in the manufacturing industry. Another one is AI for employee productivity. I highlighted our form recognizer service that can automate the paper flow and make people focus on higher priority tasks over, scanning documents. Third one, we have Shell there, reducing cost and managing risk. Shell is using our AI technologies in their edge, right, in the gas station, to detect serious security threats. People smoking next to the gas station, and detect that with video technologies at the edge and leverage it to make their environment more secure. And then last, certainly not least, AI to engage customers in a better way. I highlighted the Xbox scenario with the personalized dashboard, but Uber is using this to provide some guarantees to their customers that the driver that is driving the car is actually the driver that is registered with Uber, using face recognition technologies. And there are many other use cases that you can find on customers.microsoft.com and read more about. So with that, I'm at the end of my session. Thanks for your attention. But before you go, I'd like to announce 2 sessions that are coming up. Murat Eken is going to talk about broad developments at Microsoft, in particular in our data stack. So he'll talk about our integrated data platform, our limitless analytics service, and our cognitive services, for example. And then Iulia will pick up from there to discuss how you can apply data science when our pre-trained models are not sufficient and you need to build your own models. So enjoy the rest of the conference. Thanks GoDataDriven for having me, and see you next time.
So our first guest is Murat Eken. Welcome.
Hello.
You are a data solution architect at Microsoft, and you are here to talk about developments at Microsoft.
Yes, thanks for having me.
You're very welcome.
Yeah, it's great to have you here. And one of the first things that I was thinking about with all this COVID-19 pandemic going on in the whole world. So what are the effects on the AI technologies that Microsoft has, and are there any specific things that you see changing in this world?
Yeah. COVID has been disruptive for many businesses, right? I see customers building AI-infused solutions to cope with the situation in the best possible way. One example is that to mitigate risks, there have been some applications being built, for monitoring social distancing requirements by looking at CCTV images. We have recently announced a new service called Spatial Analysis that enables you to keep track of people's movements and their presence in certain locations. So what you can do is then collect that information and build heat maps of where people are violating those rules, maybe even, so that you can change the maybe even the layout of your store to prevent these things from happening. The technology itself is not only for COVID, obviously. It's being able to track this information gives you lots of possibilities. If you look at the retail world, you can, for instance, imagine that if you are designing a new floor plan or if you are displaying new merchandise, you want to optimize the paths for how people are going around in your stores and making the best of how we can how these retailers kind of sell their merchandise in the best possible way. You could also think of monitoring your queues at checkouts. If you find out that at certain times that queues are being built up and people abandon those queues, you might consider doing something about that. So there's a lot of possibilities by using this, just this example of spatial analysis, and it's actually part of what we call cognitive services. Cognitive service is a collection of services that we have on Azure. And the whole intent of cognitive services is that we are providing sophisticated pre-trained AI models so that people can build applications around that with little investment. Because that's the key, right? COVID is now, COVID is here, so you don't have too much time to build your custom models. If you get this functionality very quickly and you can build application using that to solve your problems very quickly, you have a much lower time to market. And looking at the cognitive services, I feel like it's one of the most underappreciated parts of Azure.
Yeah. So can you give some examples on other cognitive services that you recognize?
Yes, these are, as I said, sophisticated models. Like for speech recognition, we have services for object detection in images, in video streams. We have OCR, optical character recognition. Translation services are part of it. Language understanding is another thing that we have. So it's a broad spectrum of different types of models that help you infuse your applications with the intelligence that we have. And at the end of the day, these services are available through SDKs using common languages or frameworks like the Java, Python, but they're also available through REST APIs. So it's very easy to embed those things in your applications. There are customers who kind of feel like, hey, I also have a data science capabilities in my teams. Can I not build them myself? Right. Obviously, you can do that, but just imagine the investment that you have to do. Having the team is one thing, but you have to allocate resources for building these models. I mean, you're talking about speech recognition that consists of multiple models, right? Multiple layers of models. You have to, your transcript, you have to get your audio into something that's understandable for your models to get the phonemes out of it. You have to have language models so you can convert those phonemes to words with probabilities doing that. So you'll need huge amounts of data. Having data is not the only thing. You'll also have lots of capacity to train these huge, complicated models. That takes a lot of time and takes a lot of investment. And once you've done it, you'll say, hey, okay, now I've done it for English. Now let's try it for Dutch. You start over again, or at least partially. You have to build all those things. And we are living in an era where these developments are, happening on a daily basis, right? So you have to keep them up to date. If you look at, the functionality being already available for you out of the box for, I think, a few cents for every so many thousand transactions, I think it's nonsense to put so much effort yourself into something like that.
Yeah, so, not to mention the cloud resources that you need to actually compute power and storage power.
I mean, we were talking about this beforehand, right? Previously, when I was building neural networks myself, I was proud of the size of them by counting it in the number of thousands. But we are not at the millions level, we are at the billions level. Right. Earlier this year, Microsoft has announced a natural language generator called Turing NLG that can generate natural language based on a natural language texts based on a piece of input. Having 17 billion parameters, I have to think about 17 billion. And now we have GPT-3, the hype around that, which is dwarfing that by 175 million, 10 times more. So you can imagine 175 billion parameters. I mean, if you will have quantized all those into 8-bit integers, that's already 175 terabytes. Yeah. That's just the weights. And if you don't do that, it's going to be even more in the petabytes range, maybe even. So yeah, you will need huge amounts of resources to build something like that for yourself. So for those cases, we have these services that some of them are out of the box, as I said. You don't have to do anything. You just provide the input to get the intelligence out of it. In some cases, you can customize them, right? You have the capability to add your domain-specific things. We have, for instance, object recognition. It can classify tens of thousands of classes of objects based on ImageNet taxonomy. But if you have very specific set of images, set of concepts that you want to recognize, it's possible to augment it with your own data. So we apply something called transfer learning to fine-tune it specifically for you. So yeah, I do believe that this is an area where customers can get value very quickly.
Yeah. You seem to have designed your services for different levels of speciality in the sense that, if you are maybe a novice or you don't have a lot of experience with machine learning, you can still use these products.
Exactly, that's the idea, right? I mean, we do have lots of custom AI capabilities. My colleague Iulia is going to talk about that later today. We have services if you want to do really advanced AI modeling that doesn't fit in what we provide out of the box, or you have very specific requirements, it's all possible. But if you're just starting and you need this intelligence out of the box very quickly, this is a great starting point.
Yeah, but you talked about data. AI comes to life with data. So what do you see as challenges? Because companies have a lot of data, but they don't have the strategy in place to actually deal with all the data. So what would you say could be good approaches to actually deal with the challenges we see there?
Yes, as you say, right, to be able to build at least custom AI models, you'll need lots of data. You'll have to have information available about many different things. But not even for AI, even for business intelligence. You know, we hear the many organizations struggling with what we call silos of data, right? Different entities, departments owning their own data, not being able to get the whole picture, the famous 360 of the customer not being available just because, you know, customer or at least organizations keep their data in these different areas separate from each other. So most of the time, people think that they can solve that problem by providing a data platform. And data platform is a very broad concept, obviously. And when they talk about data platforms, they typically, or usually they refer to an analytics data platform where they want to be able to do this kind of analysis on all this information. So I see, you know, threefold things. First of all, you know, to be able to do that, you'll need a solution where you can store this data, bring together data in a cheap way, right? Having this analytics data in the source systems is quite difficult to get the information out of those systems to do analytics on the fly. So what we see is that there is this ingestion moment where the data is being retrieved from different sources, right, and then consolidated on one place, which is, again, repeating, should be as cheap as possible, but also keep as much metadata as possible so that you can apply your business intelligence on top of that. And this could be things like BI, as I mentioned, but also more advanced analytics, getting insights, doing big data analytics, or even building AI models. So we have something called Azure Data Lake Store, which is an HDFS compliant data store. And this has been around already for a couple of years. It's a proven technology in that sense. It doesn't have any scales when it comes to the amount of data that you can store in there. We are talking about, you know, we have customers that store petabytes of data easily on that solution. It has certain enterprise features like, you know, having role-based access control. So not everybody has access to everything all the time. So you can really fine-tune how you're accessing that thing. And it's an area where we are also heavily investing in. We have recently introduced the concept of specific endpoints, right? When we talk about HDFS, that's very much optimized for big data analytics. So the data lake store is optimized for throughput, so for big data analytics. But there are also customers using different protocols. You know, NFS is one of them, for instance. So we are opening up NFS endpoints. We are adding some different protocols so you can access that storage through these different types of endpoints. On top of that, when you do big data analytics, you have huge clusters operating on data, so they are quite capable. But if you could fine-tune the amount of data that you're bringing into those engines, you know, that you could already save a lot of time and money. So we've also introduced this concept of query acceleration. So what we are doing is that typically an HDFS store is store only. You don't do compute on there. But what we can do is that we can look at the inside these files, these data files, and only retrieve the relevant part to the big data clusters to do the analysis. And you know, you can imagine that latency gets much better if you have a very broad file, very broad data set with many columns, and you only need 2 of them. Getting 2 is going to be much more efficient than getting everything and doing the analysis on the cluster itself. So that's the first part, the storage thing. The other thing is that when we talk about data platforms, customers are very much concerned about lock-in. Right? They are afraid to make the wrong choice. They think, hey, if I go for a data warehouse or I go for data analytics, I can't change it. And this is the beauty of the cloud, the flexibility, right? Having the data being stored in this HDFS store gives you all these capabilities of making your choice at the time when you need it. So you're not really bound to a specific technology. HDFS is open source, so you can build, you can use other compute engines that are capable of dealing with HDFS, these open source standards. So in that area, and I'm going to talk about that later today on the signups part of things. So you have many options, and I would encourage people not to be afraid of making the wrong choice. Yes, obviously, if you put exabytes of data in the wrong database, it's going to take some time to extract it and then put it in somewhere else. but start small. Start with the idea of that you don't have to boil the ocean on one day, and a wrong choice can be undone quickly as well. And finally, the third thing about these data platforms is, again, an area where we're investing heavily. So we talk about storage, but we haven't talked about the data models, right? If the data you're getting from these different stores, different line of business applications is very different from each other, making sense out of that becomes very difficult. So what we have is that we've introduced a few years ago the concept of common data model, where we are trying to establish standards with Open Standards Institute, so that we have a established way of explaining or exposing data for different industries. So a customer means a specific set of things for a finance industry, for instance, versus an energy industry. We've acquired a company called ADRM this year, which is specialized in building industry-specific models. So we are getting their technology into our platform, so we can have these optimized the industry data models, IDMs, and we are also planning on tooling. We call it the Industry Data Workbench. That's a piece of software that helps you, transform the data in a visual way. That's in preview right now, so I can't show you any examples of it, unfortunately. But the idea is that you will be able to explain the transformations you want to do, and we generate the pipelines underneath to transform the data and make it available. And once you have data in a standard model, what happens is that you have these vendors, be it the data generators or data consumers, right, building out-of-the-box solutions. You can imagine that if you have a data model for finance, for instance, you can have out-of-the-box reports to give insights without you doing anything. You just provide your data because the report expects a certain data model. It already fits, so you have your results immediately.
Yeah.
So I see here you're mentioning Synapse.
Yes.
Right? And I mean, we just touched on the concept of a data lake, and we hear a lot of people talking about that. But what is Synapse? And
yes. And
why are you hyping it so much?
Yes. So first of all, I feel like I need to apologize for the names, right? It can be quite confusing. We used to have this technology called SQL Data Warehouse, which is an MPP solution, massively parallel processing solution, enabling you to do SQL-like queries on huge amounts of data. We have renamed it to Synapse Analytics. But when I talk about Synapse and Synapse Analytics, I'm actually talking about the platform itself. And being able to do these MPP processing is just one part of it. So if I have to, I guess this is going to be our marketing slogan, it's a limitless analytics service. That's what we call Synapse. But it's a combination of a modern data warehouse for enterprises and big data analytics. So we try to bring these two worlds together. Right. And today already you can do many things based on existing components that we have. We have as I said, the SQL Data Warehouse already. We have, for big data analytics, the Apache Spark, Databricks being able to do that. And there is also other capabilities within the Synapse world, things like building pipelines, or you have building reports using Power BI, and building machine learning models and executing them using Azure machine learning workspaces. The thing is, these are all building blocks that you have to bring them, unify them yourself. Yeah. Whereas with the Synapse Analytics, what we're trying to do is that give you an experience where all this is integrated for you. So you get a unified end solution that allows you to do big data analytics, modern data warehousing, using a just single, pane of glass, let's say.
So you get really good performance for a really good price-production ratio.
That is the intention, indeed, yes. And it also gives you the flexibility that we talked about, right? If you have the skills in your house to do SQL transformations on your data, or your data is relational, right? A SQL data warehouse solution will fit much better. Yep. And if you have more big data analytics where you're dealing with non-schema bound or schema-free data, a Spark solution might be better. So it kind of depends on the skills and your requirements, and the Synapse is actually it's already there, GA for certain parts, gonna give you that functionality in a single product, basically.
So if I wanted to build custom models using Python, for example, is there room within Synapse for that?
So Synapse at the moment, I don't think that it will be the place where you build it, but it will be the place where you would execute or score, infer from. So you could apply, you can already apply a machine learning model on Synapse to get the results on huge data sets. So you build your models using Python, let's say, and this could be again within Synapse when you're using Spark, by the way. That's actually a good one that you could do. And then export that in what we call the Onyx format, and then from the data warehousing solution, you can apply to a set of customers and get the results again in a data warehouse and visualize them or do whatever you want with it. When we talk about machine learning, I mean, we've touched on the cognitive services as being, for, I wouldn't say novices, but it's the low barrier entry point. Sometimes you want to do more custom modeling, and I don't want to spend too much time on that because Iulia is going to talk about it. But just imagine that if you want to go beyond these pre-trained models, or you have very specific requirements where the cognitive services don't help you enough. So you could use whatever framework you're using, and the Microsoft has changed. We do support open source frameworks, and we contribute in there as well. You could use those things on the platform, and we have different services that enable you to use these frameworks. When we talk about TensorFlow, when we talk about Keras, when we talk about PyTorch or Scikit-learn even, we have different services, things like Apache Spark, and we have different flavors of that on Azure. We have the Databricks version, we have our own version as part of HD Insight. But we also have what we call Azure Machine Learning Workspaces, where you can have a notebook environment where you can run these things. And having the frameworks is not the only thing, right? And having the service is also not the only thing. You also need the resourcing for neural networks that we briefly touched on. You need very powerful compute capacities and sometimes GPU-based solutions. And this is one of the things where Azure shines as well. You have access to huge machines, the machines with terabytes of memory. We have GPUs with thousands of CUDA cores to do neural network training and all that stuff. And we've also started investing in an area, FPGAs, for inferring models that have been already built through different methods. And FPGAs are initially, you can imagine that, I don't know if I have to explain what an FPGA is, but it's, let's say it's the more specific version of a CPU where you have a very custom kind of firmware on them to run a specific model. They're very efficient. Nevertheless, the main selling point will be that they're also cheaper. If you look at the high-end GPU solutions today, they are compared, if you compare them to FPGAs, quite expensive. And with the FPGAs, you get a better cost-effective solution. And the other thing, and this also applies to cognitive services, by the way, these models, once they have been built, they can also be executed on premises, on your own environment, in the cloud, obviously, but also on edge devices. I mean, when we talked about this spatial analysis, you can imagine that people, having concerns about privacy. They don't want these images to leave their own premises. They want to do this analysis on premises. So you can export these models, and you can deploy them on the edge. So you get, kind of best of both worlds. You have, build them in a platform where you don't have to invest much yourself, but you can also execute them in isolation in your own environment. And sometimes, you might also have latency problems that you can address it with this, right? If you don't have the best connectivity, you don't want to send, images every so many milliseconds to the cloud.
So it's very flexible deployment.
That's the idea, yeah. We want to make sure that you're not really locked into a single platform.
Excellent. Well, thank you very much for coming here today.
Welcome.
Murat.
Thank you.
Thank you very much. So René, that's a very comprehensive overview of services on Azure.
Yeah, it's also good to see all these cognitive services running on the edge, running in the cloud, it's everywhere. So it's it sounds very promising.
There's a lot of options. So here to talk about different ways to do data science on Microsoft Azure is Iulia Feroli. Welcome.
Thank you.
You used to be a data scientist, but now you are a cloud solution architect at Microsoft.
Yep. I went over on the other side. Yes.
So maybe it's also like a good starter question on you have been working in the field as a data scientist, now as an architect. So when you look at the concept of data science from those two different perspectives, what is the difference?
Yeah, it is quite a different way to look at it. So as an architect, I try to, as much as possible, still work with data science departments, since I know how that worked, but it's definitely a different outlook on it. When I was working as a data scientist, and especially studying as a data scientist, I think the academia side of it, you focus on very specific things, like how to make models better, how to improve the performance, how to deliver something, and then the beginning and the end of that process isn't really covered so much. For example, I'll get a CSV file and then I work with it and then I have the result in another file and you throw it over the fence to someone else and that's that. Whereas as an architect, when I see data science departments, when we address a solution to that, it goes from, okay, how do you integrate with the data that already is on your platform somewhere? How do you make sure that the results directly impact the business and are connected to stakeholders that can interpret them? And everything has to have a value. There's a reason you create an algorithm. It's not just making it because you can make it really efficient or really innovative. So I think that was quite different for me to see that there's a bigger world out there. I think it's quite different, especially from the soft perspective of it, but also the technology perspective of how it works.
Yeah, so as we can see on the slide, it's a whole story of ingestion to visualize and integration.
Yes, there's a lot of roles over there, and data science is like one thing in the middle, which I guess if you are a data scientist, I don't know, hopefully you know that those other roles are there. Or I started working in a very young data science department where we were all of that, like the unicorn that people look for that can do data analysis and SQL migration and everything together. But I think it's really important to cover all of that and to be aware of all those different roles working together. So you wouldn't expect a data scientist to be an integration engineer and get data from your Oracle database or whatever it's located on premise or in the cloud, whatever. And you also wouldn't expect them to create a application out of it that can go in production and people can go on a website from all over the world and it won't crash. You can expect a data scientist to know that.
Yeah, because if you translate this story with all these roles into technology, so how would that look like on Azure, for example?
A lot of products as well, just as many roles as many products. I think Murat probably already explained that we have a lot of ways to do one thing, which is a good thing. You can customize it to your specific needs. And then for each of these, there's an ideal technology that can cover it. You can also just do everything in one place. You can make your own Python code. You can do stuff like that. But this is what we recommend as the optimal way to handle the entire end-to-end data story. And of course, data is the foundation of the entire organization. If you want to do data science, you need data. So you see in those slides that there's different roles and different technologies that each of those roles would work with. And even though data science is in the middle, I think all of this is needed for a data science solution, right? If your departments aren't working together, then I see that a lot of data science projects fail because you don't make it a part of the bigger story. It's like a black box that they play in and experiment by themselves, like mad scientists sometimes. Yeah. But if it's integrated with everyone else, then it's proper data science, I would say.
Yeah, it's part of a bigger picture. But if we focus a little bit more on the data science part itself, so what can you tell about that? What Azure has to offer on that one?
A lot of things as well. Thanks for that question. So I always like to start with the technology agnostic perspective on it. How does it work? What are the requirements to be successful with data science? And then you can map it to Azure after. And again, there's a lot of ways you can do it. Murat mentioned the cognitive services, that's AI out of the box. That can be very helpful as well. But when you think about data science that you make yourself, so you go building models from scratch or building code from scratch, then you're probably doing machine learning. For the machine learning process, these are like the three main stages that we talk about. You need to get data in and process it and clean it and make sure that it's the right data that you need. Then you have the train and evaluate model. I think that the more and more you zoom in, the smaller role the model seems to actually take, which it's another big difference between architect and data scientist. So I think data scientists spend a lot of time just thinking of the model, but then you realize how many other extensions you can have around it, but yeah. And then you operationalize and manage it. So all these things are part of a successful data science or machine learning story. And you need to have a solution for all of them. And it could be different parts as well, or it could just be ideally in one platform, which is what we have for this, which is Azure Machine Learning.
Azure Machine Learning Services, and that.
Yes.
So elaborate a little bit on that one, because I understand that it's a very broad tool with a lot of things in the back on the back end that you as a user maybe don't have to know all about.
Yeah, definitely. It's a platform, right? It's not necessarily a tool. It's a lot of tools brought in together. Yeah. So if you have on the slide, again, an overwhelming amount of products, that is what Azure slides tend to look like. I think if you say data storage, there's 100 ways to do it. And it's our jobs with the customer to figure out the right way, the right piece of technology for each of them. So say you wanted to do an Azure and a machine learning solution, these would be, for example, the technologies behind it. So a way to store data, a way to have like a compute power. So instead of doing it on your own laptop, you send it somewhere in the cloud for processing. If you want to deploy something, you do Docker, you create a container, you use Kubernetes, which is like a whole technology to talk about for an hour by itself. So again, you wouldn't expect a data scientist to be familiar with all of these. If you already have them on Azure from different products, from different projects, it's good to know that those are still the ones that come together for machine learning. But if you're a data scientist and you just want to work on a project, then these are kind of abstracted for you. So
because it's far too complex. You don't want to know all about the specifics, but yes. Azure Machine Learning Services helps with that.
Yes, exactly. So it's like a balance of knowing that each part is handled in the best way possible, and you can configure that to your needs. But if that can be someone else's job, right? As a data scientist, you can just be assured that all those components are integrated in your end-to-end platform. And then you see them something like this. So you have data stores and data sets. So say your data is in a data lake, in a SQL database, in a warehouse, wherever it is, I just see it as a data set that has been created for me. And I don't need to know the path of where it's located. I don't need to know how the governance was set up. But to know that it has been set up is, compliancy and all that. But you just see it as a data set with a name. So if I say take the historical house sales data, that's it. I just need to know its name, and it's somewhere behind the scenes. The same for the compute. Can be a lot of things behind it, right? If I want to run a Hello World script, which I'm sure everyone has started with, if you've done something technical, then you don't need a super overpowered GPU cluster to do that, right? So you don't need to have that because it's expensive. There's no need for it. It's an overpowered tool. So behind the scenes, someone can set up a very basic virtual machine for you. If you want to train a deep learning algorithm, however, you need another tool. So that they can all be behind the scene, but you still reference to it as just your compute. Same with your experiments. You can track whatever you're doing there, which I think is really helpful. So again, instead of the black box where people are playing with their code and maybe sharing it, hopefully with GitHub, worst case via email or copy-pasting it in a chat, which, we've seen happening a lot. But this is a way to track, what's happening. Say this person ran this model with these parameters, and this was the result. So you can go back to that. If you have a really good solution, but you can't figure out which version of the code ran it, that's not very optimal. So you can do that with Azure ML.
Mm-hmm. So
a whole lot of things.
Yeah. But so if we make this a little bit more explicit, so what is the point? Because you have all these separate services, and of course everything has its own powers.
Yep.
But what would you say would be the great benefit of using a service like this one instead of all the non-abstracted away services?
Very good question. And we get that a lot, why another tool, right? And there's also open source solutions for that, like MLflow, for example. There's different ways that you can bring things together. It's just, if you look at it from, you can patch things together, you can combine stuff, pick and choose whatever you want, but we want to have a platform where everything's integrated in the best way possible. If you have a Azure native solution, everything comes together. Your data is brought in by a pipeline that is reusable and governed and secure, and it's always going to have the same result. Your models, you can have access to them from here, so you don't have to open 10 different tabs. And also, it's something that is for everyone. So on the slide now, that's what's called the designer. So if you're someone who can't code, but you want to have a data science solution, which we also see a lot, like maybe a business analyst or a low-code, no-code persona, you can drag and drop parts of a machine learning model and create a data science solution, even though you write no lines of code. At the same time, you can integrate the Azure ML SDK with your preferred IDE. So it's a lot of acronyms. But if you're using like Eclipse or Visual Studio Code or a program that you code in, that can also be sent behind the scene to track the experiments and get all the benefits out of it. So the point of doing it is just to make it more simple. It brings everything in one place. And a lot of different roles can collaborate on this platform together. So if you code, if you don't code, if you're a developer, data engineer, you should all communicate with your team and work together.
Yeah, okay, it makes sense. So one place that brings it all all together for different roles. So I think that's the beautiful part of it. It's not only for that one specific role, but it's for multiple people.
Yeah, exactly. Like the technology, because we can make a good technology solution, but I think if you make it so that it addresses like the dynamic of the team as well and the way you go about a data science project, that's even more helpful. So it's not, maybe for each of these you have a solution that works, that's like separate in some way, but the fact that everything is together, I think is the biggest value, because if everyone can explore the data, right? So let's give an example of a start to end scenario, since that was the title of the presentation. So this is what the portal looks like. On the left, you have like all your different things that I mentioned before that you can go in their own tabs. So say you have new data that you want to explore, and the data probably came into your data lake or whatever it is that it's stored. So someone already gave the right permissions to who can access it, which is very important. Maybe they anonymized it. So the data scientists only get access to the type of data that they should have access to. And then also a business analyst can have a first look at it. We have a tab somewhere where you can just see the data like as an Excel sheet, which is easily understandable by more people. You can have some more initial graphs, like the distribution of the numbers, what the categories look like. You can connect it to Power BI, and someone can already be like, oh, I would like to explore this scenario. Then as a low-code, no-code person, you can already use the designer and try something out yourself. So you can do machine learning with an idea that came to mind. I think that's a really good point, that you come up with an idea, it should take you a really short amount of time to see if it's valuable, rather than talk about it and try to get a data scientist to look into it. Maybe they're busy. You can also try it out yourself. But say it's a good idea, then a data scientist does come in, and then they can use a notebook to code a data science, a machine learning problem. They can code it on their computer, or they can also use the designer if they want to, but they probably won't if they want to really customize it. So then they create a model, they track their experiment, they work together as a team, they use GitHub, everything works integrated. And then they come up with a solution. They have a model that works. They can literally just push deploy, and it gets sent on a cluster somewhere, and it's maybe a live solution, which again can be configured behind the scene by an AI engineer or machine learning engineer or whatever they're choosing to call it. But for you, it's as simple as this model works. It has the right accuracy. I want it out there, and then someone can integrate it to a live solution.
Cool. So the whole life cycle of like coding, the DevOps, the DevOps way of work from code to production in a short feedback cycles, are all integrated in this product as well.
Yeah, we call that MLOps actually. So DevOps and machine learning. So it's a concept of MLOps, where everything, acronyms. We're so good at acronyms. But you can build pipelines and release pipelines so that, you can set up a way of work that you use for all your projects. So instead of spending time figuring out, how do we set up the environment, what tools do we need, what permissions do we need, you can just have a template that says, okay, we have a new project, create the environment for it. These are the roles that are in the team, and make sure everyone has access, and you can just go and do your work. You don't have to worry about the setup so much.
Cool stuff.
Yeah, thanks.
This is great. Thank you very much, Iulia.
Thank you.
Thank you.
Wow, so that's really a platform for everyone.
Democratizing machine learning, it seems like.
It's a big theme.
It is big, and it's only a small part. Like the data science is only a subset of the whole story that we just learned. So yeah, awesome stuff.
So we now go to my favorite part of this week, which is the GoDataFest band. It's a great band. They're playing together, and we're going to hear their final version, the final version of the GoDataFest song, in 2 days. But right now, let's just check in and see how they're doing. Is really starting to shape up well together. I mean, that's what do you think?
Even smoke during practice sessions. That's cool.
So at the first part of the session, we looked at the Microsoft Azure services, and in the second part, we're going to look at applications. So we've got experts from the Rabobank and Eneco coming in. But first, we're going to talk to Fokko Driesprong about AI maturity and the building blocks of data platforms. Fokko, welcome.
Thank you.
You are a principal code connoisseur, data engineering consultant working for GoDataDriven, and you are an open source enthusiast.
Exactly, yeah.
Welcome.
Yeah, at GoDataDriven, you pick your own title, so this is what you get then. So.
I just picked data engineer, but...
I would always say pick AI maturist or something, because I don't know what it is. So what is AI maturity and how do I get there?
Yeah, in the end, so there's a couple of levels when it comes to AI maturity. So when you want to become a real data-driven organization, there are a couple of steps that you need to take. And the ultimate goal is like being AI mature, that you adopt AI within your organization, and that you use it for all your decision making, or maybe even let AI do the decision making, of course. So that's the holy grail that we're aiming at. The AI maturity it's like a digital transformation you have to go through as an organization. So here we see the nice chart. So it's mostly, I would say, like a business process, but there are also some key enablers that you need to have from a technical perspective. And one of them is, of course, the AI data platform. That's what we're going to talk about. Mm-hmm. GoDataDriven, we built a process using a couple of building blocks that we can use to see what you need from the data platform. Some key principles that we follow.
Yeah, so multiple building blocks that actually guide you through the process. And maybe you can walk us through that process.
I'd love to.
Yeah.
So these are the 5 steps. At the very left, we have the most important one, is ingestion. Mm-hmm. So in your data platform, you want to ingest all the possible data. So what this means is you have a lot of data sources within your company, also outside of your company. Maybe some operational database that you want to ingest onto the platform using techniques like CDC, streaming information where you capture like sensor information, or maybe clickstream information from your app or website. It can also be like custom components like Fivetran or Stitch that are getting more and more popular. They help you to, for example, get all the data from a YouTube or a Facebook or an AdWords onto your cloud very easily. And if you need to do some custom integration, you can always use Airflow to stitch maybe like the legacy system that you have in your company, still of ETL the data into the platform.
Yeah, so put all the data into one place, a data lake or something. So yeah. Can you explain a little bit on why it is so important to have all that data into one data lake on one central location?
Yeah, very good question. So now we used to do ETL, and now we do ELT. So the second step is now load. We load all the raw data onto our cloud. And this storage is quite cheap, so it's not really a problem to just store all the data there. So we have a copy of all the original data. And yeah, if you have all the data there, you can do an end-to-end transformation to your model, to your reporting. And if you have everything onto different systems, so if it's scattered, then it's really hard to do this end-to-end, and then you lose lineage. So then, yeah, the whole landscape becomes much more complicated, and yeah, complexity is something that we don't like. Often translate to expensiveness. Yeah. So yeah, therefore we argue to do meta-driven transformations. What this means is a very declarative way of transforming. So we have all the raw data onto the platform, and from there on we just transform everything in a very transparent way. What's very important here that we have often a variety of sources. For example, we have very simple non-PII data, we have PII data. But if you're maybe a financial institution like ABN AMRO, you have also maybe financial data that also needs to be kept secret. So if you have a very nice declarative way of doing this, then it's really easy to enforce these things. So you just store all the stuff that you tagged with metadata onto, for example, secure islands, so that you can actually guarantee that it's safe, that a certain set of people have access to it, a certain set of applications. That is very well defined.
Yeah, so I can imagine that things like GDPR and data governance are part of that metadata definitions.
Yeah, yeah. So people we have to do GDPR, of course. We all have to be GDPR compliant, and if you don't do this by design, it becomes much more complicated. So yeah, if you want to do GDPR later on, you often end up with very awkward solutions, very complex solutions, and that's not what you want. So at the very beginning, if someone invokes the right to be forgotten, at the beginning of your pipeline, you want to remove that user or anonymize that user, so it cannot be found in the data anymore. Same goes for retention periods. Like if you do them at the start, where you have all the data, and you don't have to pay any attention anymore later on when you have the models that train on this data. Yeah. So that makes it much more easy to maintain. Yeah. Same goes for data governance. So you have, of course, all these different sources. They have owners, and also when you produce these data assets that you store in your data catalog, you also want to attach the report or data owners to that data.
Yeah, makes sense. Makes sense. Yeah. So the next step. What is the next step after transformation?
Yeah, you want to get value out of the data. So you want to do reporting. This is your classical data warehousing step, I would say. So it's getting insights into the information. It's also exposing all the data and the data assets that you have inside of the lake to the organization. It's very important that that a lot of people from the organization have access to this data. So if someone has to make a business decision, that they have easy access to the data, so they can make the decision on top of the data instead of their gut feeling. And this is where the reporting comes in. Yeah.
So you say people have access to all the data. Organizations need to have access to the data. So is this then the infamous gold data layer that we are talking about, or is this something different?
Yeah, there's a lot of these terms. I think bronze, silver, gold is one. You have the raw and curated, and staging sometimes in between. Yeah, that's something that you have to decide on a company level. I would say, like if you're a very complex company, then you will have more layers there. And if you're easier of a smaller company, I would say, then you might have you need less layers. And then the gold layer or the consumption layer, often called, that's where you have aligned on the definitions, a bit of a master data management, where you know, like, okay, we have a collective definition of a customer. That's the end goal that you try to achieve over there.
Yeah, okay. Moving on.
Yeah, I think the cool stuff. So in the very left, we have the ingestion, which is the raw data. And reporting, we have the information, the insights. But also, with data science nowadays, you can do very cool stuff. For example, like predictions. It's like maybe you want to forecast some stuff and feed that back into the reporting layer. So if you're a production company, you often have like forecasting. It's very interesting for the organization as well. So you can do some command planning, some capacity planning, and this kind of stuff. But it can also be that you train models that are exposed outside of the organizations. For example, if you have a recommendation model that serves recommendations to the end users, then you go to the whole circle again. So you serve the recommendations to the users, and the user changes behavior based on these recommendations. So you can do some A/B testing if you have multiple models, and that will then flow back into the ingestion layer, where you do the clickstream analysis, and then it goes back to the model.
Yeah.
So then you have the whole loop closed.
And so this resembles a little bit of the software engineering part, where short feedback loops, adding new features.
Yeah.
So very vibrant stage, I might say. So how does this scale? Because if you adding constant stuff, training new models, adding stuff, how does this scale? What do you do here?
Yeah, we try to embrace the MLOps principles. So the best practice from software engineering, also to implement them into the data science world. What you do is constantly iterate on the model. So you have this feedback loop where you can improve on. And if you keep track of this all, then you can constantly improve on it. And also the team should be autonomous. So you should be able to just as a team to work on a single model and not to have to worry about all the stuff that's around you. So you can just nicely improve on that and iterate on that.
Yeah.
Monitor it all the time because the world will change so often. Yeah, probably have to retrain your model, maybe change the model sometimes.
Cool. Last step.
Yeah, the monitoring. I think that's a step that's often forgotten. It's if you have a cloud environment, it's very powerful, it's very elastic, but it can also be extremely expensive if you don't use it well. So I think monitoring is it's a step that's very important. So this is in multiple parts. So that you this can be that you have some policies on all the resources that you have within the cloud. That you say, okay, I know that this cluster belongs to this or this department, and that you also enforce this, right? Using tagging, so you know that okay, the cost of this cluster is also being billed on this department. I think that's very important. But also looking like, okay, what's going on in the cloud? So we have tooling nowadays to just go to the whole cloud, see, okay, we have this cluster running there, it belongs to that department, but it's only idle all the time. So maybe we should talk to the departments like what it's doing there. Maybe we can scale it down, or maybe it's not being used at all. So that's the monitoring part where you can, you have to constantly keep track of your cloud and see what's going on there.
Yeah. So a question that I have on this one is, I was at a customer where they had a idle data lake burning like $60,000 a month.
Yeah.
Nobody noticed.
Yeah.
So how do you enforce this kind of things?
Yeah, it's always you have to. I think first is observability, so you know what's going on. And there's tooling that we've implemented at customers where you can see, okay, you get just like a nice PDF with all the, with maybe a top 100, just prioritized at the stuff where you can save the most money. And then you have to talk to this department like, okay, is this still being used? And then you can maybe decide to throw it away. But I think it's always a discussion that you have to have before. And maybe it's a backup or something, right?
Yeah, that might be the case. Then you have another discussion after that one.
Exactly. Yeah.
Okay, so all the steps complete. So how do you deploy it?
Yeah. So there's a very high level of the pipeline or the data platform building steps. I think every company has to see, okay, what do you find important, and how we're gonna translate this into technology. Yeah, and then you end up something like this. So this is like one of the Azure architectures that we've made for a presentation sometime. And at GoDataDriven we of course do every cloud, but today we're at the Microsoft Day, so delivery chose like an Azure implementation. And what we do, we have like a whole collection of scripts, because we believe that also infrastructure as code, also the DevOps approach to infrastructure is very important. And we have a set of scripts where you can just easily deploy, most of the time, like a big part of the cloud. And often, every company is different, so often you have to tweak and customize it a bit. And that's where we can help, just to pick on technology, or maybe to help them to guide them through this process.
Yeah, so automation is key here as well. So
yeah.
Infrastructure as code, but also models and applications, or
yeah. So in the end, so also with MLOps, in the beginning you will develop it a lot, and in the end it will go more like to a running state where You maybe check it, you also have alerts, of course. You check it like once a month to tweak it a bit. So it's also important that you have some standardization in how you deploy models, for example. Yeah, and if you don't do this by code, then the acceptance environment will look different in production. And if you then promote it to production, stuff might break. That's not what you want. So we want to deploy everything deterministically by code. Yeah.
Thank you. Cool.
Thank you.
Thank you for being here today, Fokko.
It was a pleasure. I loved it.
I think we're seeing you tomorrow as well, right? For the open source day.
Yes, that's true.
Right. I'll see you tomorrow then.
Looking forward to it. Thanks.
Bye.
Thank you.
I can imagine a lot of companies struggle with building these data platforms and AI maturity.
Yeah, there are a lot of steps involved as we saw. So I can imagine it's not simple to reach that level of maturity.
Right, but I mean, this is a really good framework, I think.
I think it's useful for all the companies that want to get started.
Yeah. So our next guest is Ronald Groot. He's going to talk to us about helping end users with the energy transition at Eneco using data. Ronald, welcome.
Thanks.
You are the manager of data science and business innovation at Eneco?
Yes, that's correct.
Excellent. And we're looking here at a slide of your own house we just heard.
Yeah, absolutely. As I'm going to talk about the personal energy transition, let's make it very personal and show a picture of my own energy transition, which took place last year, or actually, sorry, this year. With this bad weather, I can hardly imagine that also we had these clean blue skies, as you now see in the picture. Though I installed quite some solar panels on my roof as my goal to reach zero on my energy bill.
Yeah. So.
And that's. I think I'm getting there. I still have an electric vehicle, or I have an electric vehicle at the moment, so that does consume quite a lot of energy. But in total, I think I'm getting there. But that's my own personal situation.
In the context of Eneco, how do you support people, like all your customers, in their energy transition?
That's a great question, because I think for a lot of customers, this whole concept of the energy transition is a rather vague concept. I'm not sure about you two, yourself, how you're envisioning your personal energy transition at the moment. But I think it's fair to say that for most people, I'm not so normal, I think, in that case, because I've been working at this as my hobby for quite some time now. But it's rather vague, and it's unclear. How can you take the next step? What is my next step? And how can I really pursue that goal? Or maybe I'm not too interested in it, or I only have a financial concern. And that really depends from customer to customer. I think I deliberately chose this angle to introduce our data platform because Eneco has invested and has chosen very, very clearly to the digitization path and the let's say this data path that we're going to. So we really have built a strong team of scientists and engineers throughout Eneco, mostly in my teams, and together, let's say, we are at all stages of energy, from both the production side all the way to help the customer maybe add some insulation to their homes or some solar panels. We're helping them with the use of data. And I'm happy to explain how that works and why that works and how we're going to do that.
Yeah, I'll elaborate a little bit on the role of data in this energy transition, because I can imagine in this new world where data is gold, it plays a part.
Yeah, I'm still not sure if it's gold, like that's been said already for a long time, but I also see, except that it's gold, you also still have to work very hard, but maybe that's the truth for gold as well, to dig it up. That's also not too easy. Now, how it basically works, you have, with this energy transition, you kind of have two effects. One of the effects is that because, let's say, the number of sustainable energy production plants are mainly unsteerable, like my PV panels. They only work. They do not work today with this bad weather, or hardly. But if the sun is shining a lot, then it works. And it's not directly coupled to the energy need as that you have, for instance, with a traditional power plant, gas-fired power plant, coal-fired power plant, nuke, or whatsoever. So all this introduces a very big problem that you have to predict extremely well what our customers are going to use. So when are they going to switch on en masse all their air conditionings? Like I do not have one, but if you have a part in the city where a lot of people have air conditionings, then it's a very big problem for the energy net to predict that exact moment, because at that moment you need to rebalance the whole energy grid, because it's very difficult to store power. That's basically the whole technical mechanism behind it. So let's say Exhibit A, why you need data in order to make that prediction, to understand, to learn from the past, and to have your predictive algorithms make sure that at the right time you predict the right value for what the consumption is going to be. The other is more of a long-term effect in behavior of customers, in investments that customers do. And that's let's say, how I call it the personal energy transition, or how to make the energy transition personal. For most customers, as we just discussed, it's rather vague. What is the best next step, and what is the best that I could do? And because at Eneco we have invested a lot in the collection of data, obviously all within the GDPR concerns and restrictions, etc. We know very well what happens in people's homes. We also know very well what is the actual behavior of people's homes. And you should think of that we can actually tell that, let's say you are going to buy a very energy efficient dishwasher, but we can also see if in that very energy efficient dishwasher, you're actually using the eco program or you're using the burn program to clean up your dishes. Because you have a certain pattern that actually tells what you've been using for the last years. And exactly this level of detail, that's the interaction that you need to have with your customer if they are looking to lower their energy bill, if they're looking on, okay, more places where I can save energy. Is a heat pump a good idea for me? How many solar panels would fit, let's say, my energy bill? I don't want to produce too much. All these questions are basically, at the moment, not even asked, but we're already working on the answers.
So, and how do you gather this data, and how do you develop solutions with what technologies do you use or platforms?
Yeah, that's a great question. I think for some reason I don't have the slide controls. Something didn't work anymore. But just 1 second. No, it did work before. That's always really great. Let me just quickly close this and do it like this. Sorry for that inconvenience.
Don't worry about it.
Yeah, we're there again. So if you look at, let's say one of you guys wants to start an energy company. I can imagine about this exciting story I just told you. You quit your job and you want to start an energy company. There are quite some things to think of. One being you have to do something with the generation of energy. One is that you have to have some kind of connection to the energy market, because there's also trading involved to let's say balance all the positions day ahead, month ahead, year ahead, but also to settle it for the things that actually happened in the past. And you obviously need all kinds of things to interact with the customer to make sure that you have the right contract, the right contact, and all these other things that sound maybe quite logical, because there are not that many products. It's power, it's gas, it's district heating. That's the main products that we have. Obviously, we're going for additional services and all kinds of other things that we're now developing, but the main is still this part. But the complexity is that every customer is extremely different, both in order of usage, but also in order of behavior, in things that are possible with the connection, the energy connections that they have, the grid that lies in between. It's rather complex. So that's I think the first one. And this picture that you now here see, it doesn't help a lot. I think if we go through every block here, it's just to show you how complex it is, but also how well our data and analytics platform needs to be connected to everything in order to, let's say, make these next suggestions in both balancing the grid, what I said with making sure that this sustainable energy plans balance with the need that's there, as well as to predict the behavior of each individual customer, to do all kinds of clever things with marketing, to do all kinds of clever things with, let's say, services that tell you if your solar panels are broken or not, and all these other things need to be connected there. So the most important thing in our, let's say, data landscape, and also, let's say, our first step, basically, that we took around 2018, where we have a very strong shift within Eneco from doing all kinds of POCs and having all kinds of separate data parks and data departments with all kinds of mini platforms, if you will. We invested heavily in a very big event streaming platform. It's built on Kafka. And that basically enables all the data that we have to be used in all parts of Eneco, of all customers, obviously within all the limits of the GDPR, etc. So that's kind of how we started. And from that onwards, we're now working on one central data and analytics platform, our enterprise data platform. And that is, let's say, the solution for basically all your data needs and data problems. So yeah, to be a bit more clear, obviously I can draw all the use cases on it, and then again it would be extremely complex. But just to give some idea, let's say on top, written in red, you have your data sources, your data storage, your data processing, your orchestration, your serving, and your channels. Basically, you could see it as a very rough. You have data flowing in, you do something clever with it, and then it flows out. That's basically the short summary of a very short summary of this part. Yes, shall I continue, or sorry? Maybe I get a bit enthusiastic and start talking.
How will this platform evolve in the coming years?
Yeah, that's a great question. I think maybe it's even better if I look at the picture that we have right here, because this is basically this is more or less the use case of how we do marketing more cleverly, how we use that from input data all the way to the channels. But to be honest, this you can also do with Visual Basic in essence, but it's just a lot of work and it will be tremendously slow. So you need some, let's say, state-of-the-art toolings built on top of our Microsoft Azure platform to be able to serve this data. And I was also listening to the very interesting previous conversation, and I think there are quite some similarities there. As also there, I heard that you have your data gathering, your ETL, and how you can then transform that via model to some other part. And for us, what is new? How do you start? I think at the moment we have quite some processes already in a Python script. It can be run, and to be very honest, there are also some Windows schedulers involved in some processes. So that's not the let's say the prettiest solution that we have at the moment. And slowly but steadily we're working ourselves to become more and more mature. We also have looked at I'm not sure if you've heard that. I don't have the slide on that, but the data maturity model of Google there. You have these machine learning operations maturity levels. And we've looked at that, and we've set ourselves a goal that start of 2022, this should function. And basically that means sometimes you still see multiple tools in each area. For instance, in the model development and experimentation, it will be Azure ML. In the data quality tools, it will be Collibra. Already we've progressed, and we've had some let's say some selections made. And at that point, we're slowly building more of the good solutions within all these squares, basically, the squares with the rounded off edges.
Yeah, and as you can see, all in the cloud, all in Azure, all PaaS.
Absolutely. Yeah. It's virtually everything is in the cloud at the moment. We are working on some more or less on the edges of our data landscape. You can imagine that you have a device at home. Maybe some, let's say, data processing will be done there. Maybe some analytics even will be done there. Maybe on the tone, for instance, or smart energy thermostat. That's possible, but virtually everything is in the cloud. Also, to enable that data sharing and to be able that all the insights that we have of our customer can be served via all means of contact with the customer. So it doesn't matter if you're in the app or if you call somebody in the call center, they should give you a very intelligent answer on, let's say, why is your energy usage so high, and tell you, okay, maybe you should use the eco program of your dishwasher. That kind of interaction you want to have.
Yeah,
right.
Very nice. All data driven.
Yes.
Absolutely. Yeah, we need to.
Ronald, thank you very much.
Thank you.
You're welcome.
Thanks. I'm not measuring my energy consumption right now, are you?
I'm measuring my solar panels.
Right.
But the rest is a mystery to me.
It is also for me. I definitely have to look this up. Our next guests are Jelle, Zaanen and Ruben van Loosbroek. Both are at Rabobank. And they're going to talk to us about how to leverage data at Rabobank so that they can become your financial coach. Jelle, you're a product manager and product owner at Rabobank. And Ruben, you are a business consultant, advanced data and analytics.
Yep.
So welcome.
Thanks. Thanks for having us.
Is het niet fascinerend hoe eenvoudig je tegenwoordig een betaalverzoek stuurt? Of dat je als ondernemer meteen een melding krijgt als er betaald is? Fantastisch. Een app die je uitgaven in kaart brengt. En zelfs voorspelt wat er binnenkomt en weer uitgaat. Bijvoorbeeld voor kinderopvang. Maar het wordt nog mooier, want nu kun je betaalrekeningen van andere banken toevoegen. Zodat je straks nog maar één app nodig hebt, die steeds meer je financiële coach wordt. En je helpt om verder te kijken. De Rabo-app blijft zich vernieuwen. Kom maar op met de toekomst. Rabobank.
That sounds very promising. So the role of the Rabobank as a financial coach, can you elaborate a bit?
Yeah, I think I can do that. So what you just saw was a commercial that aired on national TV end of last year. And in that commercial, we basically make a promise, right? So the app is becoming a financial coach. And at the time, we didn't have that many features yet that basically translate into us being a financial coach or show that we are. But what is being a financial coach? I think, the app is one of our main interaction channels at the moment with our customer. It's the most important, right? So if you think about a bank, the app is basically is what comes to mind, right, for most customers. And it is actually this app, so the Rabobank banking app, that we want to turn more into a financial coach, so that it actually helps you make smarter financial choices easily every day.
Can you tell a little bit about features that are in the app?
Yeah, so I think on the screen you also see an image of a functionality that is currently live for customers in the app. So it's a financial insights page. And what you can actually see is, for example, that you can see your total income, but most importantly also your total spending in a month. And I think this is also what customers expect, right? If you think of a financial coach, or actually what a financial coach does, one of the first things is actually help you organize your spending and actually make you aware of what you are spending. So that is what we are doing with the app. This is currently live, and as a customer you can dive into your expenses much better than you could previously.
I understood that the people that actually built this app, or it's a bunch of people, 30, 40 people, the whole department is building.
Yeah, more and more. Yeah.
It's called RATE. So what does it stand for, RATE, and what does your department do? Can you explain?
Yeah, sure. Yeah, so I'm heading RATE. So Jelle and I joined forces, I think, a little over 2.5 years ago, when we thought of building such features as Jelle just presented. What we needed there was more intelligence in the app, because looking at your raw transactions in there, is pretty cumbersome, and we wanted to add more context to the transactions so we can translate it better into financial control and financial guidance. And the algorithms for us is the answer to transferring those raw transactions into more meaningful transactions. And what the RATE team does is we build and maintain those algorithms and help colleagues in the bank deploy those features or those algorithms into features, both customer-facing, like the banking app, but also more internally for other use cases in the bank.
And RATE is the acronym for?
Yeah, RATE is our acronym for the Rabobank Analytic Transaction Engine, which is like an umbrella of API-based algorithms solely focused on transaction data.
I can imagine that you're dealing with real-time data here, right? Data is streaming in. So can you tell us a little bit about scalability and business value?
Yeah, so I think if you look at the real-time aspect, what is really nice is that at the moment a transaction comes along, you can actually see in the app how it's categorized and also what your current status is in the month. So I think that is really important, that the analysis is really close to the moment the transaction is actually happening. And if you look at the role of a financial coach, you want to be able to eventually maybe also respond or give meaningful information on a real-time basis, because that is the moment that you can actually help. So I think this is a really important characteristic of placing the analytics really close to the moment the transaction is happening and placing it close to the actual transaction.
So because there are so many people involved, and I think I can imagine a lot of different technologies to build all these features. So how do you organize that internally?
I think you see mainly 3 types of departments / squads involved. One is more business facing, like Jelle as a PO for a part of the banking app. That's one. The second is more of a platform layer, so we need to host our algorithms, make them available in streaming environments, handle sometimes up to 2,000-3,000 transactions a second. So there's a lot of platform stuff involved. And then there's people involved on the algorithm level and building and maintaining those algorithms. And we come together in, not in one team, but we are dispersed over the bank in different tribes and different areas. But we have same rituals, and during the project of designing and building such features, we just bring ourselves together and work as one team. And it can be, from time to time, can be actually quite a big group.
Yeah, I can imagine.
Yeah.
And in terms of development, you have, of course, the app itself, but we are talking about data here, so probably a lot of models and algorithms. So how do you develop and maintain those solutions?
Yeah, so I think we have to start with, it's a lot of data. So you need specialized environments for that. We have a data and queue setup within Rabobank and deploy on Azure. But we handle, like, if you look at consumer clients, we handle over 300 million transactions a month. So for developing and also deploying models, you usually need to look at a few years of data, building and tuning your models. Yeah. So you have to be it's quite data intensive. We have specialized setups for this. We develop with DataIQ, and then we build our models in Python. And we deploy them either as a REST API or as a Python or Spark UDF package in Databricks. Depends a bit on the type of model we're building. Depends a bit on where we are in the development phase.
So what kind of models and features?
It's usually machine learning type models we use. Yeah. But it differs kind of what kind of use cases. For instance, in the categorization, we have a few models. Categorization is one of our biggest, we call them transaction enrichers. So one of our biggest transaction enrichers. We have one for consumer clients, and we have one for SMEs, so business clients. In those models, we combine rule-based approach with a lookup-based approach, we call them. For instance, we have a list of all the ATMs in Europe in there, which, it isn't really fancy technology and machine learning based, but for us it's a very important attribute of those models. And for some of the areas in the transaction domain, we use more of a complex neural net approach in TensorFlow for categorizing those transactions. Well, we specialized in building our own models with different types of machine learning, more deterministic approaches to create transparency in the way we develop and also make it measurable, but also make it performant.
Yeah, I can imagine that quality is also, you're a bank, so quality is always an issue.
Yep.
So how do you measure the quality of your algorithms, for example?
Yeah, that's a good question. So Jelle and I have had quite some discussion in the early stages of what is an appropriate level, where do you want to be, what is acceptable for customers, and how much effort you're going to put in as a company to reach a certain quality level. So if you look at the categorization models, we look at coverage. So for us, the amount of transactions and the number of transactions that automatically categorized to a category is an important benchmark for us. So we call that coverage. And next to that, we have precision. It's also from the transactions that are categorized automatically, which of them are categorized correctly. And we have a sort of an internal SLA on this that we say we have a benchmark of 90% for both of them. And we are well above that mark. So and that's something we continuously monitor.
Yeah, I think what's also important to realize is that this number directly impacts how much effort the user in the app has to spend on, having an actual correct overview and having good insights. So for us, it's really important that these numbers are high and that they are actually increasing, so that the model performance is continuously improved.
Yeah. And if you look at the picture, you see something we call feedback. So as a user in the banking app, you have the option to recategorize something we categorized. So the model outputs a certain category. If you do not agree with the category we proposed, you have the option to recategorize it yourself. And that has actually, it's a win-win situation. For as a customer, the overview improves and you get more control of your financial situation. You're also able to create rules out of that. So for the next time that transaction comes along, it's personalized for you, done in that category. But we also take in that data and use it to improve our models.
Yeah.
So we take in about 50K a day of those feedback moments. So we were over 15 million since the launch last year. And we use that to bump our coverage and also precision.
Yeah, so it's a short feedback loop, continuously retraining the models to
it's actually the first thing we deployed when we launched last year, because it's such an important aspect.
Yeah, so talking about a little bit of learning and continuous feedback, and so the tech stack that you use to build this stuff.
Yeah, for us, Python is the core, and we use a lot of data processing around this. We use also DataIQ for processing, for instance, the feedback flow I just mentioned, but we develop mainly in Python, and where we need, we either build something ourselves or source in or use something from the open source community like TensorFlow for building specific, mostly part of the models and integrate those. Together with the platform team, we deploy that either on Azure via Pivotal Cloud Foundry, or Azure Databricks and for Spark deployments.
Yeah, so a cloud solution.
Yeah, it's the only way here, I would say. Yeah.
Yeah, these amounts of data and compute power.
Yeah, so there's a lot of focus on optimizing the models, not only statistically, but also technically. But yeah, there's also always an end to this puzzle, right? And sometimes you need to be satisfied, and then we stop optimizing and start using.
So how do you see the future of this app, or maybe it's more than an app, maybe it's a whole data platform?
Yeah, so for the app, we're continuously expanding this functionality. So over the last months, there have been a lot of improvements in the app itself. I think one of the nice things we are working on now is a fixed cost overview for customers. So that is an introduction of a new model as well. But it will be, it's one of the main requests as well, or it's a customer need as well, right? To have a really good overview of your fixed costs. So that is something we are introducing. So currently it's mostly about awareness, showing you where your money goes, how much you are spending, what you can expect to be coming up in the short-term future.
And the fixed cost model, what it does, it sort of picks out those transactions that just recur every month?
Exactly. And the thing about it is that 90% of customers or people, they don't actually have a good full model of all the fixed costs that they have. So it's really a problem that you want to solve through the banking app. So this is a new feature we are working on, and eventually this is about showing you insights. Of course, we can take it a step further and really fulfilling the financial coaching role by also providing you with smarter tips at the right time to help users make better or to make great financial decisions.
Excellent.
And completely developed in-house.
We think the transaction data is valuable for our customers, but also from us as a bank itself. And we think there's a quite important of data protection question in this. So we want to keep the data in-house, not have it processed by a third-party processor.
Right.
And for us, we are as a bank are responsible for some of the financial decisions customers make, or we need to aid them or help them in those decisions.
Yeah.
So we as well need to fully understand what's happening in those models. So we explicitly develop for transparency, and also keeping it in-house is one of the important aspects we do.
Yeah.
For the model, or the new feature, Jelle just proposed, we create a pattern detection algorithm based on transactions, which functionally is pretty easy. Want to explain it, but it's good to build. It's very difficult to build at high quality standards, and also in terms of data processing, which is quite heavily looking at the volumes we process.
Of course.
Sounds great.
Great. Thank you very much, Jelle, Ruben. Thank you for being here.
Yeah, you're welcome. Thanks for having us.
I'm looking forward to using those features.
Yeah, can you imagine what a big impact an app like that has on a complete audience of people, like 4.5 million users on that app only?
Yeah, I'm not great at budgeting, so I really need this personal assistant.
Great mission, yeah.
So our next guest is Alex de Groot. He's a SaaS technology and strategy consultant at Xpirit, and he's going to talk to us about Cloud Accelerator for independent software vendors. Alex, welcome.
So we are talking here about cloud accelerators for independent software vendors. It's a mouthful, but the question behind that statement is, I think, the move to the cloud. So why do you think that all these vendors are so rushing towards the cloud?
Yeah. So what you see is actually the market is changing. The majority of these software vendors used to actually go together with a box physically to their customers. They moved that to sending CDs, and these days it's actually you're sending something like a download to your customer. But the customer wants something different. They want to have free updates. They want to have easy integrations. Those sort of things. And that changes the entire game, actually. So very quickly, then people are talking about SaaS, software as a service, and I actually want to change that around, because I would say, no, it's service as software. So you want to deliver service, and you happen to deliver software. So that is actually the reason why the majority of these vendors are in this process. On top of that, also the customers want to have a more sort of how to call it. They want to have predictable costs. In the past, they used to pay a large amount of money, and now they are paying per employee, maybe per customer, like a customer for them. So that changes this game completely. And then they see, okay, we have a problem in our software delivery to make this happen, and that's the reason when they start to use leverage the cloud, which is a great thing, because it changes everything what's going to happen. Very typically, what they do is they start first off with the concept of subscription. So they changed, rather than what they call perpetual licensing, they changed that from this bulk amount of money they received at the first time you pay the product. They moved it to an annual or monthly subscription. And then the step afterwards, what they need to do is they need to really change the way how they look at their software. They need to learn again how to use new technology such as the cloud technology to make their software great again. Why do they need to do that? They need to step back, actually need to stop a moment to make sure that they redevelop this proposition for their software, to understand what that means, to understand how their software development teams need to work, how their product managers need to work, and how they need to talk to the customer. And then afterwards they can use these learnings to actually move step by step to expand that onto all of their teams. What's very important here, though, is that they make this step of re-evaluating their product. Is their product still what the customer wants? Once again, service as software, not the other way around. And then start to use cloud as the tactical enabler. So use cloud as something which will allow you to do quick experimentation and those sort of things.
Yeah, makes total sense. So, but imagine I have my full product proposition ready. It's all up and running on paper. How do I make that kickstart towards the cloud? How do I get started? What do I do?
Yeah. The first most important thing is make sure that you have a big buy-in. You want to choose the biggest project, preferably in your company, the one which hurts the most for the customers, the one which is which the entire market is asking about, and make this very visible inside your company, and then collect a group of people who are enthusiastic about it, and give them the responsibility to bring this to action. What you also want to make sure is you want to focus. You want to make sure that this group is starting to focus really on delivering this product and putting everything aside, everything else aside. So forget about how to do billing, forget about authentication, forget about all of these things. Cloud vendors deliver you building blocks. For example, Azure has this identity framework, which works very well for SaaS vendors as just to solve that problem. It's a foundational problem, and they can focus on the proposition then. There's also a very important aspect there to keep in mind. A lot of the vendors used to build everything themselves because they've grown up from this hardware age towards the software age and now to this cloud age. They used to do everything themselves. And this results very often in something which I call not invented here, or actually I'm not the only one who calls that not invented here. But you really have to kill that thing. You need to start to re-look at that proposition, see, okay, this is the area where I make the difference. And all of these other parts, I'm okay with this 80% right. So kill this not invented here syndrome, and move onwards, use whatever you can. Take all of these giants, take a piece from Google, take a piece from Amazon, take a piece from Azure, and build on top of that.
Yeah, so leverage the power of open source platforms or other SaaS offerings that are out there in the market. So, yeah. And if you look at that the proposition, these are the things that you need to do to actually start moving forward. But many companies do that. Many companies struggle. You have a lot of experience in the field. So what do you see as most common mistakes that companies do while rushing, you might say, to the cloud?
Yeah, that's a good thing. It's a good question because very typically what happens is they start to create this enormous strategic move. Let's move to the cloud. Let's move all together. But that's probably not the best thing if you want to basically do a new invention. You want to focus. You want to say, hey, this one team is going to do it, and we're going to learn from them. So I would say that the most common mistake is starting with too many teams, too many products at once, and basically not able to handle that change. A second thing I would say is that the adoption of this new way of working. I was just talking about this not invented here syndrome, where you see that you need to change the way how you select stuff, to change the way how you do your sourcing. That means that you have to adopt your decision making. You have to give a team the possibility to make their own choices. If you are coming from this original company where you might have this group of architects who is typically making these sort of decisions, and this group of product managers who's typically making all of the product calls, how is this new team going to make all of those decisions? So you often see a second sort of mistake is that a company is not able to adapt to this local decision making, which is necessary in order to have this team succeed in the cloud.
Yeah, and so the team should be just focused on delivering the full business value instead of just one part or many teams working together towards the goal. But
yeah, one of the things is what you see there is that because of this unique focus, at a certain things are also gonna basically change in the structure of the company. So you're seeing something which I call a paradigm shift from typically more logical oriented towards more value oriented, more functional oriented. So you change the way how teams are built up. You no longer have a database team. You have a functional team which is actually solving a functional area, and that changes all of these dynamics indeed.
But and when you look at like the primary driver for many companies that I am at is that cost efficiency or something, or operational excellence is a main driver to going to the cloud. But when you look at the promise of the cloud, it's much more. It's AI, it's data analytics, it's a lot of other things. So when do you think should be the uncovering of all these new great features? Should that be at the end or in the middle? Or what do you think?
Yeah. There is no one answer about that. I would definitely say as soon as possible. But you need to make a few decisions there early on in order to make sure that you actually can uncover these things. I recommend every company who is moving to the cloud and is moving with existing customer data to do that as soon as possible. Very often this is a problem which is pushed backwards. The interesting thing about all of the power of the cloud is all about having the data there to make intelligent decisions or to give better recommendations and all of these sort of things. So the sooner you have this customer data in the cloud, the better it is. It's hard to do it at the first moment, but it's better to have it there. And then I would definitely suggest all of the companies to start off with really something small. You know, like maybe change something in your user interface which makes it easier to upload pictures or to do some recommendation, just like small tiny things, just to gain experiments. I was earlier talking about building on top of the shoulders of giants. Many AI inventions are already effective in the cloud. For example, Azure has this cognitive services. Cognitive services will help you to do data entry a lot easier. In general, it will make user experience a lot better. That's a great way to start to understand what the cloud can bring and what AI can bring, basically. So that's a fantastic start there. And then later on, you can start to leverage this customer data. Maybe you can combine the customer data if you're allowed, GDPR-wise, those sort of things. You can combine that to also become more intelligent. And those are the moments where you also have to think really well again, because once again, your service as software. So you don't want to be creepy, but you can start to can start to become more intelligent in processes, in recommendations, and maybe you can even eventually replace decision making there.
Yeah. So again, the sentence, with great power comes great responsibility. Just if you can, it does not mean do it.
No, and that's really difficult when it comes to AI. But I would definitely recommend everybody, just start small and build this up gradually.
Great. Thank you.
Thanks for being here, Alex. And with that, we finish the 4th day of GoDataFest. Today was all about Microsoft Azure. We heard some great applications from experts at Eneco, Rabo, and Xpirit. We've talked about data platforms and AI maturity, and I think it was a successful day. What do you think?
I learned a lot. It was a very broad spectrum of topics, but I think it's very cool to hear about all this new technology, and it's promising.
Yeah, absolutely. So a big thank you to today's sponsors, Microsoft and Xpirit. Thank you to the speakers. Thank you to you, René, for co-hosting today.
Thank you for having me.
Absolutely. And of course, thank you for watching. Tomorrow is going to be our last day, so make sure you tune into that live stream about open source. Thank you.